Hi there, welcome to my channel Mandu to Fundu. In this video, I'm going to discuss about the solution for checking whether a given string is a valid anagram of another one. Let's look at the problem description. We are given as two strings s and t, and we have to return true if t is an anagram of s. An anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. So let's take a look at this example. In this, S is anagram of T. So that's why we returns true, because if we rearrange the letters of this word, we can form this. And here S is rat and T is car, and we cannot rearrange this to form this string, so that's why it is false. And the length of the string ranging from 1 to 50,000 letters. And S and T consist of only lowercase English letters. They are also expecting to have support for the Unicode characters. Let's look at the approach to solve this problem. And so we have the input string, anagram and anagram, and we have to return true. Okay, so we can use the hash map to keep track of the frequency of each character in the first string and verify whether the second string also has the exactly same number of characters with the same frequency. First, we have to initialize the hash map with hash map data structure, and then we traverse the first string, and for each character we see, we update the frequency of that character in this hash map. For example, in this case, A is there 3 times, so it has a frequency count 3. N is 1 time, and G is 1 time, R is 1 time, and M is 1 time. Then after populating this frequency map, we have to go over the second string, all the characters in the second string, and then decrement the frequency count one by one. Whenever we see a character, the corresponding frequency count will be decremented. For example, in this case, when we first iteration we see n, then the frequency count will be decremented here. So before decrementing, what we have to do is we have to check whether the frequency count of the character is 0. If so, we have to return false, because the second string has more number of the same character than the first string. So that's what it indicates. So we will return false, saying that the first string is not anagram of second string. Otherwise, after processing the entire loop, at the end, by default we return true, meaning if all of them have the same frequency count in the second string, and then that means first is the anagram of second string. Let's look at the flow chart. Input for this procedure is first and second string. First we initialize the return value and the frequency map data structure. So the frequency map data structure is of type map of run, and the value will be integer. So in Golang, the Unicode data points are stored in data type run. Then the ret val is initially set to true. First then we check whether the length of the first string is equal to the second string. If not, then we cannot form a second string from the first string by rearranging the letters. That means first is not anagram of second one, so we return false. We come out of that procedure and returning the false. Otherwise, we loop over the first string, and for each character we see in that string, the first of IDX, we update the frequency count for that character in the freq map data structure, and we increment that index and loop over the rest of the characters. At the end of this loop, the frequency map data structure contains each unique character in that input string, first input string, the corresponding number of occurrence of those letters. After that, we go over the characters in the second input string. So for each character we see in the second, we check whether the frequency count of that character in the freq map data structure is 0. That means we are seeing more number of the second of IDX character than the one present in the first string. That means they are not anagram. So we return false in that case. Otherwise, we decrement the freq count in the freq map for that character second of IDX, and then we keep proceeding with the rest of the characters. So once we process all the letters in the second string, then finally we return the ret val. If everything is matching, then the ret val contains true. Finally we return that value. Let's move on to coding. For readability purpose, I rename the parameters to first and second. Then I initialize the return val variable to true. Then I check whether the length of the first string is not equal to the length of the second string. If so, I return false, because second string cannot be an anagram of first one as the number of characters differs. Next, I initialize the frequency map data structure of type map of run and int. So the run data type will carry the Unicode data point values. So, and then I go over the characters in the first string and build the frequency map for each character. I increment the frequency count. Then I go over the characters in the second string to verify whether this has the same number of characters as it is in the first string. Inside this loop, I check whether the frequency count of the character being seen is 0. That means the character ch occurs more number of times in the second string than the first. In that case, the second string cannot be an anagram of the first. So I set the ret val to false and break out of the loop. Otherwise, I decrement the frequency of the character ch, and once I come out of the loop, I return the ret val variable. If everything is good, the ret val should contain true. Next, I am going to run the test cases. Test cases passed. Next, I am going to submit this program. Cool, it's accepted. Next, I am going to do the code walkthrough with sample input. We are given two strings S and T. S is anagram and T is anagram, and the expected output is true. Okay. So first, the ret val is initialized to true, and then I check whether the first string length is not equal to the second string, but in this case both are matching, so this condition is false, so we are proceeding further. Then I initialize the frequency map. The key value is of type run, which is for storing the Unicode data point, and this is the count. And then I go over all the characters in the first string and increment the frequency count for each character. Okay, so in the first loop, in the iteration 0, we see letter A. So the frequency map will have an entry for A with the count 1. And then in the the first iteration, it's N, and the frequency count is 1. Then we see letter A, so the frequency count is set to true. And for next we see the G, so 1. And then R, then the frequency count is 1. Then A, the frequency count is 3. Then M, the frequency count is 1. Okay. Then after the first loop, what we have? The frequency of 1, 2 and 3, and N is 1, G is 1, R is 1, M is 1, right? So next I go over the characters in the second string, and then in each iteration I check whether the frequency of that character is 0. If so, I return false. The reason is the second string has more number of this character than the second string. That means they are not anagram. So I set the false and break out of the loop and come out. So iteration 0, we see N. So N's frequency is decremented to 0. Now it is 0. Then in the second iteration we see A. Then from 3 to 2. Then G, 1 to 0. Then A, 2 to 1. And then R, 1 to 0. And then A, 1 to 0. And then M, 1 to 0. So we processed all the letters in it, and for none of the characters hit this condition. So we complete this entire loop, and when we come out, whatever the initial value we set true will be available in this rootval, and we return back. Next, I'm going to do the time and space complexity analysis for this solution. Let's do the time complexity analysis for this input. In order to determine whether the string S is anagram of T, we have to traverse all the characters in both the strings. So the time complexity of this is order of n, where n is the length of the input string. So both the loops ranging over the first and second string, which are of length 6. So they both run 6 times. So that's why the time complexity is order of n. So with respect to the space complexity, it depends on the nature of the input. So here we are allocating space for frequency map to keep track of the count of each characters in the input string. So the size of that hash map depends on the nature of the input. If all are unique letters, then the frequency map size is equal to the size of input string. For example, in this case, all are unique, A, B, C, D, E, and the T is EB, EDB, EDC, BA, right? So in this case, when we finish the first loop, we have the hash map of size 5. So, but for this case, where the characters are, we have the duplicate characters in the input string. In this case, the size, the input string length is 5, but the frequency map data structure size will be 3. So we need only one entry for all the duplicate characters A. So the hash map size is 3. So in the worst case, if all the letters are unique, then the space requirement is order of n, so the space complexity of this algorithm is order of n. Thanks for watching this video. Have a great day.